1, 2, 1, 2, 1, 2, 1, 2. Weight and balance. This section covers all things dealing with the weight of the aircraft, the balance of the aircraft, and the combination, the weight and balance of the aircraft. In the section on your written, there's going to be some questions about center of gravity, weight, balance, the different effects of weight, and there's going to be some things we got to calculate some stuff. Let's go through and talk about some of this. Start off with some key terms. Here's a list of key terms that are going to be important for you to know when it comes to weight and balance. But the ones that are highlighted, the arm, basic, empty weight, center of gravity, CG limits, CG range, datum, moment, and station, are the things that are going to be most useful right now in this lesson. Looking at this airplane, you got some of these key terms highlighted and pointed out, which makes it easier for you to understand what I'm talking about when we talk about some of these different terms. For example, the datum, which is the imaginary vertical line, which is right here, that is decided by the manufacturer as a reference point for all the measurements that you're going to use when calculating the center of gravity, figuring out how far something is, which is the arm, and ultimately figuring out what the moment is to kind of do the calculations. Next thing is the arm, and the arm is the distance from the datum plane. If you go in front of the datum plane, it's going to be negative. If you go behind the datum plane towards the back of the aircraft, it's going to be positive. And so the moment is actually the calculation of the weight times the distance from the datum plane. So for example, this 10-pound weight, if it's 70 inches from the datum and it weighs 10 pounds, that'll be 70 times 10 equals 700 inch-pounds. And that's the moment of that weight. This will be important later on when we get into adding all the weights and the moments and coming up with the center of gravity, etc. So we'll talk about that a little bit later, but just giving you a quick overview of some of the important terms. When it comes to the weight of the aircraft, the more you increase the weight, the more the performance factors are going to change. So this is a list of a lot of the things that can change as you increase the weight. So your takeoff speed, your takeoff run, how fast you climb, the range, your cruise speed can be reduced, and your stall speed can be increased. Now this can be exacerbated if you exceed the max gross weight that the airplane can have. So if you're over the weight, you can put yourself in a position where the airplane is not going to perform safely, which is why it's important that you follow the rules and they're within the weight and balance limits. Those are some of the things that you'll see and we'll calculate later. Now, the balance. Balance has to do with the CG range, or the center of gravity range, and the CG is the distance between the forward and back limits of the position of where the center of gravity can be for an aircraft. And the center of gravity is where the aircraft would balance if it could be balanced from a point. When we look at the effects of a more forward CG, so if the aircraft has a CG that's forward of the limit, here's some things that you can have issue with. So longer than takeoff run, real heavy nose, and you'll have a really high stall speed. If the CG of the aircraft is after the limit, you're going to have some extreme control difficulties. It's going to be really hard to control the airplane. It's going to be really violent if the airplane stalls, and it's going to be less stable at all speeds and really difficult to recover from a stall. So just remember, after CG limit, it's going to be really, really hard to control the airplane. All right, example question. If you load an airplane to the most aft CG, it will cause the airplane to be what? We talked about this. If the airplane has a CG that's behind the limit, what will it end up being? It's going to be less stable at all speeds. Boom, less stable at all speeds. You got that one right. All right, if an airplane is loaded in such a manner that CG is located after the CG limit, one undesirable flight characteristic a pilot might experience its airplane will be, well, we know that if it's aft, it's going to be something to do with the controllability, and we talked about that. Longer takeoff run? Nah. Stall at a higher than normal speed? Yeah, it'll do that, but the most undesirable is going to be the difficulty to recover from a stalled condition. B. Your aircraft is certified for a few different categories, and when you do your weight and balance, depending on how the weight and balance matches up or lines up, you can end up in either normal category or utility category. If it's a normal category, this is for you to do kind of your regular maneuvers, your takeoffs, landings, steep turn, slow flight, and stalls. But if you're trying to do stuff like spins or other maneuvers, you got to make sure the aircraft is weighed for utility category. Couple things to note, some standard weights. These are the things that when you're doing your numbers, you use these as the basis for how much stuff weighs, like fuel and oil. Fuel is 6 pounds per gallon and oil 7.5 pounds per gallon. Ample example. An aircraft is loaded 110 pounds over the max certified gross weight. If fuel, gasoline, is drained to bring the aircraft within limits, how much fuel should be drained? Well, first thing we know is that fuel weighs 6 pounds per gallon, right? So if it's 6 pounds per gallon, how many gallons we need to take out? Well, we know we need to remove 110 pounds. And so we divide that by 6 pounds per gallon. And that gives us a number of 18.33 gallons. So the answer is 18.33 gallons. That's how much fuel we need to drain. If an aircraft is loaded 90 pounds over maximum certified gross weight and fuel is drained to bring the aircraft within limits, how much fuel should be drained? Once again, we know that fuel weighs 6 pounds per gallon. So we take the amount we need to lose or drain, 90 pounds, we divide it by 6 pounds per gallon, and we get 15 gallons. Boom, the answer is C. Too easy. A weight of 50 pounds is placed on a board at a station or a point 100 inches from the datum. 100 inches, right? The downward force of the weight can be determined by multiplying 50 by 100 inches. So, just like here, 50 times 100 equals 5,000 inch-pounds. That's the downward force, or your moment of 5,000 inch-pounds. Okay, so now we're looking at this as an example to understand how the balance works. So establish balance, a total of 5,000 inch-pounds must be applied to the other end of the board. Any combination of weight and distance which, when multiplied, produces the 5,000 pounds, because we know that on the right side, 100 times 50, 100 times 50 inches pounds equals 5,000 inch pounds. So we got to make sure that on the other side, in order for this seesaw looking thing is balanced, that the other side balances as well. When we look at that, the way that you get the total of the moments is you take the weights times the moment, add it, and you get 2,500. So for the 50 pound weight, that's 50 inches. 50 times 50 is 250. And then you look at the 100-pound weight times 25 is 2,500. And when you add them two together, there's 2,500. Add them two together, you get 5,000 inch-pounds. And so let's look at this example. Refer to figure 60. How should the 500-pound weight be shifted to balance the plank on the fulcrum? So in order for it to be balanced, the moments on both sides have to equal. So the moment on the left side has to equal the moment on the right side. So what we're trying to figure out is, where does the 500-pound weight's distance need to be? So it won't necessarily be 15. So 500 times a distance, or you can call it or whatever the arm is on this side, will equal the total moment on the right side. So the total moment on the right side is going to be, well, we got two different things here. We got the 250-pound weight, that's 20 inches, and we got the 200-pound plank, that's 15 inches. So we'll do 250 times 20 equals 5,000 inch-pounds. And then we have 200 pounds times 15 equals 3,000. Now we add it all up and we get 8,000 inch-pounds on the right side as the moment. So the moment equals 8,000. So now we take a look back on the left side. And so 500 times a number A equals 8,000. We use some algebra. Divide both sides by 500. That cancels out. Divide by 500. And the distance equals 16 inches. So the distance and the answer is 16. Boom. All right, let's take a look at figure 61. If 50 pounds of weight is located at point X, so we got 50 pounds, and 100 pounds on point Z, 100 pounds on point Z, how much weight must be located at point Y to balance it? Question mark. Why? So once again, in order for this to balance, the moment on the right side has to equal the moment on the left side. Excuse me, moment on the left side needs to match the moment on the right side. Left and right. Cool. So what's the moment on the right side? Moment on the right side is 100 pounds times 100 inches. So we get 10,000 equals the moment. So now we got to make the left side's moment equal 10,000. How do we do that? Well, we know that 50 times 50, so this times this, equals 2,500. And so we need to add 2,500 plus the moment of whatever Y is. And so 2,500 plus Y times 25 should equal 10,000. So minus 2,500 from both sides. So minus 2,500 minus 2,500. You end up with, moving this down, we end up with Y times 25 equals 7,500. Now do some more Algebra, divide by 25, divide by 25, and y equals 300. So there's your answer, 300. Basic weight and balance question. You got the weight times the arm equals the moment. And then your total moment over your total weight equals your CG. The question is, the CG is located how far aft of the datum? Well, let's take a look. So we got the empty weight 1495, arm 101.4, gives you the moment of 151,593. Pilot and passengers, remember, to find the moment, we just multiply it straight across. So 380 times 64 is going to give you 24,320. And so for fuel, if we got 30 gallons, remember, if you put 30 gallons here, you're going to get the answer wrong, because 30 gallons does not tell you how much actual fuel it is or how much weight it is. So we need to figure out, all right, what's 30? Just put over here 30 times 6 equals 180, right? So that's 180. Too easy. All right, 180 times 96 is 17,280. So 17280. So now we need to know our totals. So the total weight is 2055. The total moment is 193193. Remember, do not add the arms to do nothing. Now, in order to figure out the CG, total moment over total weight. So we take 193193 divided by 2055, and that gives me the center of gravity of 94. So the answer is 94 inches. That's what you get. That's what your CG is. So remember, get all your moments, multiply across, add your weights, add your moments, then divide moments over the weight, and you get your CG. So the first thing you got to do is start off with all of the weight of all of the things. So that's going to be the airplane, the passengers, the baggage, and the fuel. So the empty weight, and I'll show you how we set this up. So weight, arm, and the moment. First, the empty weight of the airplane is 2015. I know that because empty weight is 2015. The moment is 1,55400. We don't need to worry about the arm because it gives us the moment, so we don't got to worry about doing no actual math to figure that out. Next thing we got is the front seat occupants. Front seat occupants is 350 pounds. The arm for front seat occupants, as we see on this chart, is 85. Arm of 85. before I get the moment, we'll go ahead and get the rest of the data. Backseat occupants, 325. And if we look over here, rear seat occupants, the arm is 121. Baggage, £27, and the arm is 140. All right, your fuel is 35 gallons. 35 gallons, if we write 35 here, that would be wrong because it needs the weight, not the number of gallons. Remember that. So 35 gallons, as we look here under usable fuel, is 210 pounds. The arm is 75, and it gives us what our moment will be, which should be 15800. All right, now we're gonna add up our weights after we figure out all the moments. So let's do the math across. So weight times arm equals moment. Okay. And just use your calculator. Don't try to do this math in your head or nothing crazy, because you're gonna mess up. So 350 times 85 is 29750, and 325 times 121 is 39325, and then for the bags, 27140 is 3780. And if we do the math for 210 times 75, will be, now here's the thing, if you use the table, it's 15800. If you actually multiply it out, it'll be 15750, so it rounds it to 15800. Close enough for what we're doing, so just be consistent in how you do it. All right, now what we got to do is we got to add up our weights and our moments. Weights and our moments. Do not need to do anything else with the arm, so do not add those down or anything crazy like that, because it'll mess it all up. All right, so let's go ahead and total up our weights. Our total weight of the aircraft with the front seat, back seat, bags, and fuel is 2927. Total moments is 244005. All right, so the question asked, is the CG and the weight of the airplane within limits? Since we're using the table, what we'll do is we'll go to the weight of 2927 and then see if the moment is within. All right, so moment limits versus weight limits. Let's see this right there, right? So we get the weight 2927, which is in between here. So now we got to ask ourselves, is the moment of 244005. So 244, and we look at it, it's below this, above that, and being at 27's in between those two, That number is in between there. So the answer is yes. We are within the CG and weight limits. That's a lot. But the big picture is, using the table, you can look at the weights. For example, like when we look at the front seat weight, it says 350. The thing is, the weights only go up to 200. So it kind of sets you up to not really have the answer, be able to use the table how you should be able to. Which, that's why I don't like some of the questions on this test, because it doesn't test your ability to use the chart, it tests your ability to know the trick question. So what you do is you look to find what the arm is, and then you get the information you need. So for the front seat, 350 is the weight, even though it only goes up to 200, and your arm is 85. So 350 times 85 gives you your moment for that particular item. All right. All right, on this one, we need to determine the aircraft's loaded moment in the aircraft category. And we're using the graph to give us the information on this one instead of a chart. Okay, so we got empty weights already in there, 1350 with a moment of 51.8. Now let's look at pilot and front passengers of 380. What we'll do here is we look on the graph, and we see 380 right about there. We draw the line all the way across to front pilots and passengers. That intercepts right there. And then now we take this straight down and that gives us a moment of about, I get 14. So 14. Then we need the fuel of 48 gallons at 288 pounds. So let's do this again. Let's do it again. So we look here, there's the fuel down to 48. Then we're gonna drag the line down there. I had a little bit over, so let's fix that. That looks like it's also close to 14, so that gives us fuel moment of 14. All right, we got 8 quarts of oil. And if we look down here on the notes, engine oil of 8 quarts is 15 pounds at negative 0.2 on the moment. So we'll put negative 0.2 and 15 pounds. All right, that gives us our total weight of 20, 33, and our moment is 79.3. So now we go over here and we look at this chart with a graph, and we find where the weight graph at 20, 33, so 20, and then we're looking here 20, and then each one's 20, 20, 33. Take this all the way across, and then we look at 79 and go straight up. And right where it intersects, right there, is in the normal category. So the answer Its loaded moment is 79.3, and it's in the normal category. Anywhere in this area will be the normal category. Anything in this area would be the utility category. And upon landing, the front passenger, 180 pounds departs the airplane. A rear passenger, 204 pounds, moves to the front airplane position. What effect does this have on the CG if the airplane weighed 2690 and the moment was 2260 just prior to the transfer? Well. Very tricky question, and I'll show you how to do it. So we know what we need to figure out what the original CG was, and then figure out what the new CG is. So let's just start with that first, and then from there we can figure out the rest. So we know that the CG equals moment over weight. So we know what the moment is, or the original moment. $22,600. The weight, 2690. So our CG was 84 to start. So we know we start with 84. That's where we begin. So we'll keep 84 in our back pocket. All right, so when we started off with 2,690. We're gonna still keep moment, arm, weight, arm, the moment. So the weight we started with, 2690, and the moment of 226000. Okay. We already figured out the arm, or the moment, so we didn't need to have to worry about the arm. So now we know we do one step at a time. There's some formulas out there on how to do weight shift and weight transfer. The thing is, there's more than one moving piece in here, and to keep it simple, just do it one step at a time, and it will actually make it that much easier for you to figure out. So the first thing that happens is the front passenger. When we look at front passenger at 180, with a moment of 153 over 100. So that person left minus 180. We know the arm is 85 and the moment is 15300. Next thing, the back passenger got out the airplane. So back passenger is 204 pounds. So we just look at the rear seat arm with 121. So do minus 204 times 121. Now we gotta keep these negatives in there. Minus, we get 24,684. He got out, but then here's the thing. Then he got back in, but in a different position. He got back in the front seat, which has an arm of 85. Once we get that, we get 17340. Now we just do the math. Okay? So now, once again, you got to figure out total weight, total moment. So our total weight, we take 2690 minus 180 minus 204 and plus 204, we get 2510. We take our moments, we subtract those numbers, add that number, we end up with 203356. Remember, CG equals moment over weight, which means we take that 23,356 over 2510 gives us a CG of 81. So if the new CG is 81, what effect does it have of that whole movement? Original CG was 84, new CG was 81. It moves forward 3 inches. That's your answer. Boom. Seems like a very long, complicated question, but if you look at how the question is written and what they're asking, you can make it really, really simple. Or you can make it hard and still find the answer, but I prefer making the question easy, and then I don't gotta do too much math to try to figure out how to solve the problem. All right, question asks, which action can adjust the airplane's weight to maximum gross weight and the CG limits within limits for takeoffs? So here's what it's asking. We want to adjust the airplane's weight to maximum gross weight and within CG limits. That's key because you do that, you won't have to do too much math when you get rolling in this. Okay. So yeah, front seat occupants 425, rear seat occupants are 300. Main fuel tank is 44 gallons. Let's just set this up how we normally would before we start doing too much stuff, right? Weight, arm, moment. We know empty weight, 2015. Arm and moment, 155,400. We got front seat occupant of 425, so 425 and 85, so 425, 85 gives us a moment of 36,125. Rear seat 300, armor 20, 121, 300, 121. Moment is 36,300. Then we got fuel 44 gallons. We know that 44 gallons is a weight of 264. Arm of 75, moment of 198. Okay. Let's add it all up. $3,004, 24, 7625. Okay. So first, now that we did that, let's re-look at what the question asked. Which action adjusts the airplane's weight to maximum gross weight? Well, what is maximum gross weight before we get too much into it? Well, max gross weight, you can see here, is 29,50. Weight condition 2950 is also there. Let's see if it says it anywhere else. All right, well, there you go. 2950. So before we do anything else or do too much, let's look at where we're at. The airplane right now weighs 3,004. What's the difference between max gross weight and 3,004? Well, we just subtract, and that'll do minus 2950, and you end up with 54 pounds. So we're 54 pounds overweight. So we need to reduce the airplane's weight by 54 pounds. And that will get us to max gross weight. So let's look at the three answers we got. We got drain 12 gallons of fuel, drain 9 gallons of fuel, or transfer 12 gallons of fuel from the main tanks to the aux tank. Here's the thing. If we transfer fuel from one tank to another, the weight is still over max gross weight, so it cannot be C. The next thing is, we know that fuel is 6 pounds per gallon. We know that we're 54 pounds overweight. 54 divided by 6 equals 9. You drain 9 gallons of fuel. There's your answer. And there's the breakdown of it if you do the math. You can see the CG and the total 304. We're out of weight. And then when you remove 9 gallons of fuel, you end up with 2950 and a CG of 24,3575, and that puts the airplane in between those two numbers, which means it's within the CG limits. But you ain't got to do all that if you read the question to begin with. And there you go. So there that is. Weight and balance. That's a tough one. Biggest thing, just take your time. Remember that weight times arms equals moment. Add up your total weights, add up your total moments, but never add the arms because they don't really help you. That's really the wrong way to do it. All right, there it is.